Okay, so there is a more exact way to find solutions to systems, and that is by using a term called substitution. Okay, um, we need to have one equation solved for a single variable so that we can substitute into the other equation. Now, to me, when I look at this, right there is what I see as the most, that tells me right there, take the first equation and solve for y. So you can see that I did that here in the green. I subtracted 2x to the other side, did that first right up here, and then I divided everything by -1, which changed the signs. So y equals 2x minus 11. Now, once you've got that in place, follow this red arrow. You can see that I came down here to this y, and I did a substitution. So I took that y out, and I replaced it with 2x minus 11. So now you can see me do the algebra here. I distributed the 4 to both of those, and then I started adding like terms. I saw like terms right there, and that gave me 15x. And I could add the 44 to the other side of the equation, giving me 45. And then, of course, if I divide everything by 15, I get an x value of 3. And then I can take that, and so I know the solution is a single solution. And now I'm going to replace it up here. And 2 times 3 is 6, and 6 minus 11 gives me -5. So now I know that the y value is -5. So that's what I did in order to substitute. Got a couple more substitution questions for you here. I don't know why I'm moving that when I really only want to move this. Okay, so next substitution question. You can see that I took the first equation and I solved it. Well, oh, wait a sec. The second equation is already solved for y. So what I did was I directly substituted the 3x in the first equation for y, and then I could combine these things together and get 7x. And then if I divide by 7 on both sides, I see that x is equal to 1. And then this is obviously the better equation to substitute, 3 times x, so 3 times 1 is 3. So we know the x value is 1 and the y value is 3. So that's the coordinate of the intersection point of these two, is 1, 3. Okay, so come down here to the next one. In this one, I saw that x was solved for in the second equation, so I took that 3y plus 8 and I plugged it into the first equation. So 2 times 3y plus 8 is 6y plus 16. I already had a 7y right there, so I was able to add the like terms, the 6y and the 7y, and get 13y. If I move the 16y over to 16 to the other side by subtraction, that gives me 3 take away 16 or -13. And then, of course, we can divide by 13 and find out that y is -1. This is the best equation to go back to find out what x is by plugging in a y value of -1. And -3 plus 8 would be +5. So 5, -1 is the solution where the two lines cross. Okay, next question. So you can see in the second equation I saw that one right there is x. Oh, by the way, once I teach you what elimination is tomorrow, I probably wouldn't have done this question by substitution. So when you get to the test, if you feel like doing this with a process called elimination, because your equations are both written in standard form, ax plus by equals c, I don't care if you do it with elimination. So I would have done this with a different method. But I'm showing you how to do substitution now because you need the practice. So the second equation, x was by itself, so I can move the 4y to the other side, and that gives me -4y plus 15. And then, of course, I'm going to plug it in right there, which I did in the top of the next row right there. And then we can distribute, and that gives me -36y and +135. And so then I can see like terms that can be added together to give me -31y. And if you push the 135 to the other side by subtracting, you get -124. A little division by -31. It's kind of hard to read when you have black lettering on black lettering. but you should get a positive 4. Negative divided by negative is a positive. So now we know the y value is 4. We can come back over to this equation and plug in the 4 for y, and that gives me negative 16 plus 15, which is negative 1. So the x value is negative 1, and the y value is 4, where the two lines cross. Whoops, and that's it for that set. Kept it to under 6 minutes by writing those notes ahead of time.